Good morning, everyone. On behalf of the team from HKU and ByteDance Seed, I'm thrilled to present our work, Hint2Gen. In recent years, unified text-to-image models like Phlox and Imagen-4 have achieved incredible visual fidelity. However, they consistently fail when it comes to reasoning-intensive tasks, such as solving a maze or assembling a tangram. Our work, Hint2Gen, aims to bridge this gap by introducing code-structured hints, a mechanism that connects high-level symbolic reasoning with precise pixel-level generation. Please direct your attention to the comparison. We've identified a fundamental capability gap. On the left, existing MLLMs like Qwen Image Edit fail on tasks requiring spatial logic, such as maze navigation, generating paths that visually look okay but are logically broken. On the right, pure understanding models like GPT-5 excel at solving these problems symbolically. This reveals the bottleneck. Reasoning exists in the brain, but the hand lacks a precise interface. Our structured hint serves as a transparent scaffold, precise geometric constraints defined by SVG and HTML code, allowing the model to think before it inks.
To quantify reasoning-aware generation, we built the Hint2Gen benchmark. It comprises 4,000 high-quality samples across 7 core reasoning dimensions and 20 categories. These include path connectivity for mazes, spatial assembly for tangrams, and pattern induction for Sudoku and Match 3. We even included long-term strategy planning like chess. Each sample consists of the original image, a reasoning instruction, the code hint, and the ground truth. This serves as a rigorous testing ground for evaluating whether models truly understand physical and logical rules.
You might ask, why not use canny maps or masks? The answer is that code is inherently semantic and compositional. Traditional masks only define where to change, but SVG tags like polyline or rect define how things relate. Code coordinates correspond to absolute image space, and HTML stacking layers map directly to physical occlusion. It's lightweight yet dense in information, and most importantly, it's the format LLMs handle best, ensuring a lossless transfer of reasoning.
Technically, Hint2Gen is built upon Flux 1 Context, a state-of-the-art transformer for image editing. Our main contribution is hint injection. We render the SVG code into a hint image, encode it via a shared VAE into the latent space, and inject this hint latent into every step of the diffusion process. By applying LoRa fine-tuning, the model learns to interpret these geometric cues, ensuring strict adherence to logical constraints while maintaining high image fidelity.
High-quality data is our cornerstone. We developed an automated generation filtering pipeline. First, we use GPT-5 to compare image pairs. To fix the spatial inaccuracies of LLMs, we use gridding, overlaying a coordinate grid so GPT-5 outputs precise HTML coordinates. We filter this data via 2 stages, IOU filtering to ensure spatial alignment, and LLM auditing using Gemini 2.5 Pro to verify logical consistency. This yielded 100,000 high-quality training pairs.
Please refer to this quantitative evaluation table, which provides robust empirical evidence supporting our core technical conclusions. First, Hint2Gen achieves absolute dominance across all 7 reasoning dimensions of the Hint2Gen benchmark. Our overall accuracy skyrockets from the 3.85% of the base Flux model to 31.04%. This order of magnitude leap proves that structured code injection fundamentally fixes the logic blindness inherent in diffusion models. Furthermore, these code-structured hints carry a powerful alignment prior that consistently boosts the reasoning accuracy of existing baseline models, even in a zero-shot manner. Finally, we cross-validated our results using multiple mainstream evaluators, demonstrating that our lead remains highly consistent across different evaluation frameworks.
Here are 3 representative cases. In mazes,
Note how GPT-4o paints a green line that clips through walls, while our model follows the SVG guide perfectly. In Match 3, only Hint2Gen correctly calculates the required ball count and positions to fulfill the matching logic. For trajectory, predicting a ball's position after 3 bounces requires physical common sense. Guided by the SVG trajectory line, our model renders the ball exactly where physics dictates.
Beyond hardcore reasoning, Hint2Gen excels in general image editing, like turning a lamp into a stone tower. Because code hints provide pixel-level boundaries, our model achieves total change where requested and zero change where not. This solves the background drift issue prevalent in traditional diffusion models, ensuring high consistency and practical utility.
We also looked at why Hint2Gen works so well. Ablation shows that removing IOU filtering drops accuracy by 10%, proving that precise structure outweighs massive data. Furthermore, our model correlates strongly with human judgment, with a Pearson coefficient of 0.88. This means our results win not just on metrics, but in meeting human logical expectations.
To conclude, our contributions are threefold. We proposed SVG and HTML code as a universal interface between understanding and generation. We introduced Reason2Gen, the most logically challenging benchmark for generation to date, and we delivered Hint2Gen, a highly accurate and efficient model. Moving forward, we plan to extend these structured hints into video generation and 3D spatial reasoning. Thank you for your time, and I welcome any questions.